Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project, a multiplayer shooter game built entirely in Clojure, a Lisp dialect. It's a truly unique approach, and we're going to unpack why the developer chose this path, the challenges faced, and the overall experience.
Wow, a multiplayer shooter in Lisp? That's bold. I'm already intrigued. What were the developers' motivations behind this unconventional choice?
Exactly. The developer, a self-proclaimed Clojure enthusiast, used it for both front-end and back-end development. Clojure script compiles to JavaScript, making web deployment seamless. But the real kicker is the REPL, the Read Evil Print Loop. It allowed for live updates to the game without browser refreshes, drastically speeding up development. Think of it as real-time coding and testing. Incredibly efficient.
That's a huge advantage. I can see how that would accelerate the process. But a multiplayer game requires robust networking. How did they handle that in Clojure?
That's where things get interesting. They initially built the networking from scratch, using several Clojure async libraries like Aleph, Manifold, and Core.async. They sent world snapshots to players at 20 ticks per second, handling spellcasting, damage, and deaths asynchronously. It was a monumental task, they admit, but it gave them complete control. It sounds intense.
Intense is an understatement. Building a networking layer from scratch is a huge undertaking. Did they use any specific game engine or framework?
They used Babylon.js for graphics, choosing it for its features, documentation, and community support. Shadow-CLJS facilitated the integration with ClojureScript, making the process smoother. They also implemented a custom rule system, inspired by O'Doyle rules, to manage game logic. This system uses a global game database, a large hash map, to store all game data. Rules are triggered based on conditions defined in the hash map.
A global hash map for all game data? That sounds potentially problematic for scalability, doesn't it? Wouldn't that become a bottleneck as the game grows? That's a valid concern. The article doesn't explicitly address scalability issues with the global hash map, which is a significant point. It's a trade-off between simplicity and potential performance limitations as the player base and game complexity increase. It worked for their prototype, but it might not scale well for a larger, more complex game.
Yes, the developer highlights the difficulties of state management in game development. While Clojure's immutability is beneficial, it adds complexity. They had to create their own abstractions, and even a custom DSL, to manage the intricate game state. The lack of a strong Clojure game development community also presented challenges, making it a more isolating experience compared to working with mainstream engines.
I see. So essentially, they traded the benefits of a mature ecosystem for the flexibility of Clojure, but at a cost. What were their final thoughts on the project?
They concluded that web games are great for prototyping due to easy distribution, but resource constraints limit their scalability. Clojure's REPL was a huge asset, but the lack of community support and tooling was a significant drawback. They learned a lot, but ultimately suggest that for larger projects, a mainstream engine like Unity or Unreal might be a more efficient choice. Ultimately, though, they emphasized the rewarding nature of the entire process.
A valuable lesson indeed. It's a testament to the developer's dedication and skill to have pulled this off. Thanks for breaking down this fascinating project for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.